we've done some pretty simple vector addition stuff. So let's do a problem that's a little more complex. We'll have done this problem in class, but I wanted you to have an example of it that you can come back to here on the YouTube channel. So we're going to do problem number 5 here, where it says we have a motorboat heading east at 15 meters per second directly across a 400-meter wide river with a current of 7 meters per second south. So part A says calculate the boat's velocity while traveling on the river. So in order to do that, let's just sort of sketch it out. Here's my river, and I've got the boat going east at 15 meters per second. And then the river itself is 400 meters, and it's going 7 meters per second south. So they want to know the boat's velocity. That's going to be the resultant of these two things. So we have that formula pack that we talked about before. We've got that the resultant equals the square root of x squared plus y squared. So let's go ahead and do that. That's going to be the square root of 15 squared plus 7 squared. Now I'm being a little sloppy with my units here, but we'll get the numerical answer anyway. So we got the square root of 15 squared plus 7 squared. I get 16.6 meters per second. And then we'll use our tangent formula, the inverse tangent of the y over x, in this case 7 over 15. Okay. Inverse tangent of 7 over 15. And I get 25 degrees. So this angle here is 25 degrees at 16.6 meters per second. Okay. Part B says calculate the time it takes for the boat to cross. Okay, this is a little simpler problem. We want the time. We know the distance. And the only velocity that matters here is the velocity across the river, and that's 15 meters per second. Anything downstream or upstream doesn't matter at this point. We only care about the horizontal distance, and they're independent. So if distance is velocity times time, then time is going to be equal to distance divided by velocity. So my 400 meters divided by 15 meters per second is going to get me 400 divided by 15. And I get 26.7 seconds. All right, and I'll go up here and I'll clean this up. It's 16.6 meters per second at 25 degrees. And we're going to specify that is south of east. All right. Part C. How far downstream will the boat be when it reaches the opposite shore? So now we want to know distance downstream. So I'm looking for a distance. I have a velocity in that direction, 7 meters per second. And from my last calculation, I know that it's going to take 26.7 seconds to get across the stream. So distance is velocity times time. That's 7 meters per second times 26.7 seconds. Okay, keep that up there. 7 times 26.7. And I get 186.9. We're going to call it 187. And 187 meters. All right. Part D, a little more complicated here. Calculate the angle upstream that the boat would have to head in order to end up directly east of where it started. So in other words, there's no downstream drift when you do this. All right. So at this point, I think I want to keep the video clean. I'm going to stop it here. We'll do this in the next video.